Hi, in this video we are going to see problems on exponents and radicals in SAT math. Okay, now let's look at the first problem that's over here. That is let n equals to 1 square positive 1 to the 4th power positive 1 to the 6th power and it keeps going up to 1 to the 50th power. What is the value of n? Actually n is equal to, there is a series, number series, and we have to evaluate the value of this series. Okay, now let me write this 1 square as it is and 1 to the 4th power as it is 1 to the 6th power and 1 to the 8th power, and it keeps going up to 1 to the 50th power. Okay, now let's consider each term in the given series over here. So each term is 1 is raised to some power. Okay, when we raise 1 to any power, it's still equal to 1. So that is the value of this 1 square is 1, the value of this 1 to the 4th power is 1, the value of this 1 to the 6th power is 1. That is 1 is raised to any power still equal to the value 1. So now what I'm going to do is I'm going to divide each exponent in the given series by 2. Okay, now let me divide the first exponent over here by 2. Then I'm getting 1 to the power of 1 when I divide this 2 by 2. Okay, now let me divide this 4 by 2. Then I'm getting 1 square. Let me divide this 6 by 2. I'm getting 1 to the 3rd power. Let me divide this 8 by 2. I'm getting 1 to the 4th power, and it keeps going. And let me divide the exponent, last exponent 50 by 2. Then I'm getting 25. Okay, since I have divided each exponent by 2, so the values of the terms are changed or not? Actually, it is not changed. Okay, so for the original exponent 2, the value of the first term is 1. So even after I divided this 2 by 2, I am getting a new term 1 to the first power. This value, the value of this one is also 1. And the same thing, that is the original value of the second term 1 to the 4th power is 1. After divided this 4 by 2, I got a new term 1 square. So the value of this one is also 1. So the value of each term is not changed when I divide each exponent by 2. Okay, as I said already, the value of each term in the given series is 1. So now our aim is to count the number of terms. How many terms are there? So 1, 2, 3, 4, and the last exponent is 25. Clearly, there are 25 terms. And we know that the value of each term is 1. So that is, we are adding 25 ones. When I add 25 ones, the result is 25. So therefore, the value of n is 25. We find this 25 in answer choice C. The correct answer choice for this question is 25, that is C. Okay, now let's see the another problem. Here we have the next problem. If x square equals to y to the 3rd power, for what value of z does x to the power of 3z equals to y to the 9th power? That is, we have to solve for z. That is, we have to find the value of the variable z in this equation. That is, x to the power of 3z equals to y to the power of 9. And x to the power of 3z equals to, this y to the power of 9 can be written as y to the 3rd power whole to the power of 3. Because whenever we have two exponents like this, so what we can do is we can multiply these two exponents. When I multiply this exponent 3 and this exponent 3, that is equal to 9. So actually we can multiply these two exponents using the power of a power rule. So y to the 9th power can be written as y raised to the 3rd power whole to the power of 3. And from the first equation, we know that x square equals to y cube. That is, for this y cube, we know that x square. So we can plug in this x square for this y cube. Okay, let me do it. Then we get x to the power of 3z equals to x square whole to the power of 3. Okay, here x to the power of 3z equals to. Now let's consider the stuff we have here. We have the base x and we have the exponent 2, and for the complete stuff we have the exponent 3. Okay, now what we can do is we can multiply these two exponents using the power of a power rule in exponents. Then we get x to the power of 6. That is 2 times 3 is 6. Okay, here in this step, two terms are equal with the same base, that is x. Whenever two terms are equal with the same base, what we can do is we can equate the exponents. When I equate the exponents, I am getting 3z equals to 6. Okay, our aim is to find the value of z. So let me divide both sides by 3. When I do so, this 3 will cancel out. I am getting z equals to 6 divided by 3 is 2. Okay, now I got the value of z, that is 2. That is, when z equals to 2, x to the power of 3z and y to the power of 9 will be equal. And we find this value 2 in answer choice D. The correct answer choice for this question is D. Here we have the next problem. Okay, let's go to the question. If 2 to the power of x positive 3 negative 2 to the power of x equals to k times 2 to the x power, what is the value of k? Okay, now in this equation we have to solve for k. Okay, let me take the given equation as it is. That is 2 to the power of x positive 3 negative 2 to the x power equals to k times 2 to the x power. Okay, here when I look at this term, the two values are added at the exponent, that is x and 3. Now we can consider the product rule of exponents, that is a to the mth power times a to the nth power. Okay, here we multiply two terms with the same base. What we can do is we can take the base ones and we can add the exponents m and n. Okay, now we can consider the product of exponents in reverse order. That is, the exponent two values are added. Now what we can do is we can take this base a separately for this one, and we have to multiply the results as we have on the left side we have over here. So the same thing we can do in our problem. That is, we can take this base 2 for this x and 3, and we have to multiply the results. That is 2 to the x power times 2 to the third power negative 2 to the x power equals to k times 2 to the x power. Okay, here each term is a multiple for 2 to the x power, because this one contains 2 to the x power, this one contains 2 to the x power, and this one also contains 2 to the x power. Since each term contains 2 to the x power, we can divide each term of this equation by 2 to the x power. Let me do it. Let me divide the first one by 2 to the x power, this one by 2 to the x power, and this one by 2 to the x power. So here 2 to the x power, 2 to the x power will cancel out, and here 2 to the x power, 2 to the x power will cancel out, and here we get 2 to the third power. And when I divide this 2 to the x power and 2 to the x power, the 2 to the x power goes into this one times, and here 1 times. That is, we get 1 over 1. That is, we get negative 1 equals to k. And we know that 2 to the third power equals to 8. That is 8 negative 1 equals to k. Okay, now when I subtract this 1 from 8, I am getting 7 equals to k. I got the value of k. The value of k is 7. I find 7 in answer choice C. The correct answer choice for this question is C. Here we have the next problem. Okay, let's go to the question. If square root of x times square root of x equals to x to the 8th power, then what is the value of a? Okay, in this equation we have to solve for a. Okay, let me take the given equation as it is. That is square root of x times square root of x equals to x to the 8th power. Okay, now what I'm going to do is I'm going to write this square root as an exponent. Whenever I write square root as an exponent or any radical as an exponent, so the exponent will be, for example, let me explain it separately. Let's consider square root of x. If I want to write the square root of as an exponent, I have to write the exponent as a fraction with numerator 1. In denominator, I have to write the index of the radical. Square root means its index is 2, that is 1/2. For example, if I want to write cube root as an exponent, then x to the power of 1 over. So the index of the radical has to be taken in denominator. Since the index of the radical, I mean square root is 2. So now what we can do is, let me write the stuff over here. I am writing this one as it is, and I write this square root as an exponent. Then I am getting 1 in numerator. In denominator, I have to write the index of the radical, that is index of the square root, that is 2, equals to x to the power of a. Okay, here inside the parenthesis, I'm going to do the same thing for this square root of x also. Then I'm getting x to the power of 1/2 whole to the power of 1/2 equals to x to the power of a. Okay, for this x, what is the exponent? Actually, we don't have any exponent. We have to assume there is exponent 1. Okay, here we multiply two terms with the same base. Now we can use the product rule of exponents. That is, whenever we multiply two terms with the same base, we can take the base ones and we have to add the exponents. Then I'm getting 1 positive 1 over 2 to the raised to the power of 1 over 2 equals to x to the power of a. Okay, now let's add this integer 1 and this fraction 1 over 2. Whenever I want to do addition, between addition or subtraction between an integer and a fraction, I have to multiply the integer by the denominator of the fraction. Once I'm done with this multiplication, I can take the existing denominator as a common denominator. Okay, now let me multiply this integer 1 by this denominator 2. Then I'm getting 1 times 2 is 2. That is 2 positive 1 divided by 2. Whole to the power of 1 over 2. I just multiplied this integer by the denominator 2. Then I took this 2 as a common denominator. And on the right side, we can take this stuff as it is. That is x to the power of a. Okay, let me continue over here. X to the power of 2 positive 1 divided by 2 is just x to the power of 3 over 2. Whole to the power of 1 over 2 equals to x to the power of a. Okay, here we can use the power of a power rule in exponent. That is, we have the base x and we have exponent 3 over 2. And for the complete stuff, we have the exponent 1 over 2. So whenever we have two exponents like this, we can multiply the two exponents using the power of a power rule. Then we get x to the power of 3 over 2 times 1 over 2. I just multiplied the two exponents equals to x to the power of a. Then we get x to the power of 3 times 1 is 3. And in denominator 2 times 2 is 4 equals to x to the power of a. Okay, here two terms are equal with the same base, x on the left side, x on the right side. Whenever two terms are equal with the same base, what we can do is we can equate the exponents. When I equate the exponents, I am getting 3/4 on the left side, on the right side we get a. Okay, I got the value of a, that is 3/4. We find this 3/4 in answer choice B. The correct answer choice for this question is B. Here we have the next problem. Okay, let's go to the question. If x to the power of ac times x to the power of bc equals to x to the power of 30, x greater than 1 and a positive b equals to 5, what is the value of c? Okay, in the given equation, we have to solve for C. Okay, let me take the given equation as it is. It is x to the power of AC times x to the power of BC equals to x to the power of 30. Okay, here on the left side, we multiply two terms with the same base x. Okay, here we can use the product rule. Whenever we multiply two terms with the same base, what we can do is we can take the base ones and we have to add the exponents. Then I'm getting AC positive BC equals to x to the power of 30. Okay, here two terms are equal with the same base x. Whenever two terms are equal with the same base, what we can do is we can equate the exponents. When I equate the exponents, I am getting AC positive BC equals to 30. Okay, for these two terms, we have the greatest common divisor C. That is, both the terms contain C. So now what we can do is we can factor C out. When C is factored out, we are left with A in the first term, positive B in the second term. Then we get A positive B inside the parenthesis equals to 30. Okay, here we have the value of A positive B that is given in the question, that is 5. We can plug in 5 for this A positive B. Then we get C times of 5 equals to 30. Actually, our aim is to find the value of C. So to solve for C, we have to get rid of this 5 which is multiplied by C. For that, we have to divide both sides of the equation by 5. When I do so, this 5 will cancel out. And C equals to, when I divide 30 by 5, I am getting 6. Okay, I got the value of C, that is 6. We find 6 in answer choice C. The correct answer choice for this question is C. Here we have the next problem. Okay, let's go with the question. If n cube equals to x and n to the fourth power equals to 20x, where n is greater than 0, what is the value of x? Okay, using these information, we have to solve for x. That is, we have to find the value of x. Okay, now what I'm going to do is I'm going to divide the second equation, n to the fourth power equals to 20x, by the first equation, n cube equals to x. Whenever I divide two equations, I have to divide the stuff on the left side and I have to divide the stuff on the right side. Okay, here I'm going to divide the stuff on the left side in the second equation by the stuff on the left side in the first equation. Then I'm getting n to the fourth power divided by n cube. The same thing we have to do on the right side as well. That is the stuff on the right side 20x as to be divided by the stuff on the right side in the first equation, that is x. Okay, here this x will cancel out. And here we can use the quotient rule of exponent. That is, whenever we divide two terms with the same base, what we can do is we can take the base ones and we have to subtract the exponents. Here we divide two terms with the same base n. Then we can take the base ones and we have to subtract the exponents. Then I'm getting 4 negative 3 equals to, on the right side we get 20. Okay, now we get n to the first power because 4 negative 3 is just 1. So n to the first power means it's just n. Okay, now I got the value of n, that is 20. Now I can plug in this value 20 either into the first equation or into the second equation to solve for x. It will be easier for me if I plug in this 20 into the first equation, because when I plug in n equals to 20 into the first equation, 20 has to be raised to the third power. But when I plug in into the second equation, 20 has to be raised to the fourth power. So like we have to do some more calculation. Okay, now let me plug in this 20 into the first equation. Then I'm getting 20 to the third power. On the right side we have x. 20 to the third power means we have to multiply 20 by itself for 3 times. Okay, here 2 times 2 is 4, 4 times 2 is 8, and we have 3 zeros. That is, we have to take 3 zeros over here, equals to x. Okay, now I got the value of x. The value of x is 8000. Here we have the next question. Okay, let's go to the problem. If x to the 8th power times y to the 7th power equals to 333 and x to the 7th power times y to the 6th power equals to 3, what is the value of x times y? Okay, now to get the value of this x times y, I am going to divide the first equation by the second equation. Whenever I divide two equations, I have to divide the stuff on the left side and I have to divide the stuff on the right side. Okay, since I am going to divide the first equation by the second equation, I am going to divide the stuff on the left side in the first equation by the stuff on the left side in the second equation. Then I am getting x to the 8th power times y to the 7th power divided by x to the 7th power times y to the 6th power. And also the same thing we have to do on the right side. That is, the stuff on the right side in the first equation has to be divided by the stuff on the right side in the second equation. Then I'm getting 333 by 3. Okay, here we divide two terms with the same base, that is x. Now we can use the quotient rule of exponents. That is, whenever I divide two terms with the same base, what I can do is I can take the base ones and I have to subtract the exponents. Then I'm getting 8 negative 7. So the same thing we can do for this one, that is y to the 7th power by y to the 6th power. For that we have to take the base ones and we have to subtract the exponents, y to the power of 7 negative 6. And here 3 goes into 3 1 times and 3 goes into 333 111 times. Let me write 111 on the right side. Okay, x to the power of 8 negative 7 is just 1. That is x to the first power. And here y to the power of 7 negative 6 is just 1. On the right side we have 111. Okay, x to the first power means is just x, and y to the first power means is just y. That is, we have x times y on the left side. On the right side, we have 1 and 11. Okay, now I got the value of x times y. Its value is 1 and 11. Here we have the next problem. Okay, let's go to the question. 2 times square root of x positive 2 equals to 3 times square root of 2. If x is greater than 0 in the equation above, what is the value of x? Okay, in the given equation, we have to solve for x. Okay, let me take the given equation as this. That is 2 times square root of x positive 2 equals to 3 times square root of 2. Okay, to solve for x, we have to get rid of the square root of we have for the variable x we have over here. So now to get rid of the square root of we have over here, we have to square both sides. Okay, let me square both sides of the equation. Okay, here two terms are multiplied and we have the exponent 2 in common. Whenever two terms are multiplied and we have the exponent in common, what we can do is we can take this exponent separately for this one and separately for this one and multiply the results. Then we get 2 square times square root of x positive 2 the whole square. And the same thing we have on the right side, that is 3 and square root of 2 are multiplied and we have the exponent 2 in common. So this exponent can be taken separately for this one and multiply the results. Then we get 3 square times square root of 2 the whole square. Okay, here this square and square root will cancel out, and the same thing, square root and square root cancel out. We know that the value of 2 square is 4, that is 4 times x positive 2 equals to the value of 3 square is 9, and here we have 2. Okay, now what we can do is we can divide both sides of the equation by 4, then this 4 will cancel out, then I'm getting x positive 2 on the left side. Okay, here 2 goes into 2 1 times and 2 goes into 4 2 times. Okay, 9 times 1 is 9. And in denominator we have 2. So x positive 2 equals to, when I divide this 9 by 2, I am getting 4.5. Okay, now to solve for x, I have to get rid of this positive 2. For that, I have to subtract 2 from both sides. When I do so, this positive 2 negative will cancel out. I am getting x equals to, when I simplify this stuff on the right side, I am getting 2.5. Okay, now I got the value of x. Its value is 2.5. We find this 2.5 in answer choice A. The correct answer choice for this question is A. Here we have the next problem. Okay, let's go to the question. If 2a negative b equals to 4, what is the value of 4 to the power of a divided by 2 to the power of b? So using this information, we have to get the value of this expression 4 to the ath power divided by 2 to the bth power. Okay, now let me take this expression as it is. That is 4 to the power of a divided by 2 to the power of b. Okay, we already know that 4 is a power of 2. That is, this 4 can be written as 2 square. So already we have exponent a for this 4. The same exponent can be taken for this 2 square divided by 2 to the power of b. Then we get 2 to the power of, okay, here we have base 2 and we have exponent 2, and for the complete stuff we have exponent a. Whenever we have two exponents like this, what we can do is we can multiply the two exponents using the power of a power rule in exponents. Okay, when I multiply these two exponents 2 and a, I am getting 2a, that is 2 to the power of 2a divided by 2 to the power of b. Okay, here we divide two terms with the same base, that is 2. Whenever we divide two terms with the same base, what we can do is we can take the base ones and we have to subtract the exponents. That is 2a negative b. Okay, already we know the value of this expression 2a negative b. It's given in the question itself, that is 4. So now what I can do is I can plug in the 4 for this expression 2a negative b, that is 2 to the power of 4. Okay, 2 to the power of 4 means we have to multiply 2 by itself for 4 times because the exponent is 2. Okay, here 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Okay, here I got the value of this expression 4 to the power of a divided by 2 to the power of b. Its value is 16. Here we have the next problem. Okay, let's go to the question. If square root of x plus 2 square root of y equals to 4 times square root of y, where x is greater than 0 and y is greater than 0, what is x in terms of y? That is, in this equation, we have to solve for x in terms of y. That is, we have square root of x positive square root of y equals to 4 times square root of y. Okay, here we have to solve for x in terms of y, and when I look at the terms we have over here, we have square root for x and square root for y. Again, we have square root for y on the right side. Okay, to avoid confusion and also to make the solving process easier, I am going to assign some new variable for the square root of x and square root of y. That is, let a equals to square root of x and b equals to square root of y. Okay, now we can plug in this a for square root of x and b for square root of y. Then we can write a at the place of square root of x. Then we get a positive. For this square root of y, we can write b. A positive b equals to 4 times. Here for this square root of y also we can write b. Since our aim is to solve for x, now we have to solve for a because a contains x over here. Okay, when I solve for a and once I am done with solving, I can replace a by this original stuff and I can solve for x in terms of y. Okay, now let's solve for a in this equation. For that, we have to get rid of this positive b. So let me subtract b from both sides. When I do so, this positive b, negative b will cancel out. I am getting a equals to 4b negative b is 3b. Okay, now I got the value of a in terms of b. Now we can replace this a and b by the original stuff, square root of x and square root of y. Then this equation will become square root of x equals to 3 times square root of y. But our aim is to find x, but here we have square root of x. How do you have to get rid of this square root? For that we have to square both sides. Let me do it. Okay, when it square both sides, here the square root and square will cancel out, and we just get x on the left side. On the right side, we have 3 and square root of y are multiplied, and we have the common exponent too. Whenever two terms are multiplied and there is a common exponent, the exponent can be taken separately for each term and multiply the results. Then we get 3 square times square root of y, the whole square. Okay, here we have x on the left side. The value of 3 square is 9, and here the square root and square will cancel. We just get y. Okay, now I got x in terms of y, that is x equals to 9y. We find this 9y in answer choice B. The correct answer choice for this question is B.